Hello. Uh, Welcome to today's Monday meeting. No, not Monday meeting. It's Friday. Friday after school meeting. And basically, that's true. Basically, what we've done here right now is we're starting with a 2D project as opposed to a 3D project. So if you wanted to try and if you wanted to try and follow along, you will need to press 2D project instead of 3D project when you're starting to create your game first. Oh, that's right. All right. Just turn on the lights. Just open. Um, Although considering we're gonna move pretty fast, it might be difficult to follow along. But kind of what we want to do is give you a general overview more than like have you follow along step by step, word for word, and not kind of understand anything. So basically, what we're gonna do is make this game over here. Basically, it's well, obviously it's not super good looking, but remember, we're making this in like 30 minutes. Basically, you have like the player controls the blue square, and he tries to consume the red dots before they get to the green finish line. If they hit the green finish line, the game restarts. You can see that there's no score yet, but that's for the sake of time, and also because we haven't taught you how to make a UI yet. But in spite of that, again, you'll still be learning important game development concepts. So the first thing we want to do is this is kind of our idea, right? So what we want to do is see what do we see on the screen, and then try and make representations of them. So we see that there's the green line, there's the blue square, there's like the orange turrets shooting out the red bullets. So basically, what we want to do first is kind of make game objects representing each. So we have, well, besides the main camera, we would want finish line, I guess. We want a game object called finish line because that's there, as well as a player. This is 2D. We haven't shown you things in 3D before, but a lot of the concepts are the same, except for the fact that Unity ignores the z-axis. So it shouldn't be too jarring a shift. So we have the finish line, right? We have the player. We'll call them turrets, I guess. Those orange hexagons. Turrets. And we have bullets. So basically, the main concept is to first you want to visualize your game, kind of imagine this in your head, and second, kind of come up with paste down representations of them in the hierarchy, so you can start developing them. Now, the next thing you want to do is, in order to be able to actually see these things on the screen and more intuitively interact with them, we'll want to make them visible. We'll want to make these shapes appear, right? Green, blue, red circles, orange hexagons. So basically, normally the way we would do this is to actually first make a sprite and maybe download it, and then import it into this project view. However, for the sake of time, I'm going to show you a very quick prototyping tip. Basically, what you can do is right-click Create, just like you would for C# scripts, except instead of clicking C# scripts, there's this section called Sprites over here, around the middle. You can pick any sprite you want. In this case, let's start with the player. The player is a square, so we're going to call this square player sprite. And there you go. We have a square image. Oops. And what we can do is actually kind of say, basically, in order to make game objects have like images associated with them, you would add a component, and then click sprite and then search for sprite renderer, and it should be the second one down. Well, you can type in sprite, and it should be the second one down. Basically, the sprite renderer just attaches an image to the game component. That's it. So you see in this, there's an upper field called sprite. you can drag whatever sprite image you have into here, and it'll basically the player will now have a sprite image associated with it. If we drag the player around by pressing W and then dragging around, we can say that this is the player. Now let's do this same for the other ones, just for the sake of difference. The hexagons are turrets, and they look different from the player. So this will be the turret sprite. We'll name it turrets. And then do the same for turret. Now another speed tip in this case would be that you can actually select multiple objects that you want to do the same thing to, like this. In this case, I've selected bullet, turret, and finish line. Basically, you can hold shift click in order to select all of them. And basically, what you can do is actually click add component, and then add whatever component you want to it. In this case, all of these will have images associated with them, so all of them will have sprite renderer. So we can click sprite renderer, and now if we check all of these, all of them have sprite renderer. So that's a little bit faster. That's a faster way of doing things. You can add sprite renderers one by one, but this is just for the sake of efficiency. Now, the turret image is this image right here. So we want to drag it into the turret game object sprite renderer so that the image is associated with it. And now we have a hexagonal turret. And then for bullets, bullets are circles, so we want to create a circle sprite. Create sprites circle, and we can call this bullets. Well, bullet sprite, just for specificity. Bullet sprite, and then we click on the bullet because we want to add the bullet sprite to it. And then add the bullet sprite to the sprite field of sprite renderer. Now we have a circle, which will be a bullet. And then here's something a little bit strange. Basically, we'll make a separate sprite for the finish line. And even though it looks like it, it doesn't look like it. This finish line is actually a square, but it's just stretched out, so it's a rectangle. Basically, we can take the finish line sprite, or if you're kind of lazy, you can take this player sprite instead, and you can associate the finish line with the finish line sprite, and now you have a square finish line. Now, basically, the sprites will be transformed with the sprite images will be transformed with the game object. So basically, what we can do is, if we pick the scale tool, here, this box with arrows, or if you click R, you can stretch it like that, and yep. Now it looks about as long as the finish line. We can stretch it out if we need it, and then we can move it where we want it to be. Now that looks a little more like the game. However, if we look closely, the bullet is kind of large. So what we can do is we can kind of scale it down. This time I'm going to use the inspector. The inspector has this transform section and all these fields. The scale is the size. Let's reduce the size. We can make it 0.2. That will make it. That will shrink it. 0.2 and 0.2 might be a little too small for the x and y axes of the bullets. Let's make it 0.5 and 0.5. And now we have a bullet with half the width and half the length of a 1x1 bullet. So basically, if you couldn't see, it was in the scale field of transform right here. There are x and y. You can set these to 0.5 and 0.5. The z won't do anything because since this is 2D, Unity ignores that. So changing the z won't do anything. It doesn't matter. Okay, so now we have bullets. We have the player, and we have our finish line. However, they're all white, so it's kind of hard to differentiate. We can make things a little bit easier by changing their color. Normally, sprites, when you import normal image sprites, like actual images with color in them, the colors will actually come with the image. However, because we create sprites using create and sprite, they're all white. So what we can do is there's this color section in sprite renderer, and that will kind of set the universal color of the sprite. Change it to whatever you want. I set my player to blue, so I'm going to color it blue like this. You can pick from the color wheel here, and then you can pick its tints in the center square. So I'm going to make it kind of dark blue. So basically, the concept right now is basically we want to make our game objects tangible so that it's more intuitive to work with them. So now we can make the turrets orange, and we can make the finish line green. Or hell, if you want to make it purple, make it purple. I'll just make it green though, because that's what's in our example. It's green. So now we have now it's starting to look like our game. However, if we run it, nothing's really going to happen. It's just going to have green finish line, blue square, red dot, and orange hexagon. Just a side note, this rectangle, the rectangle that kind of covers all these things, that's where the camera is. If you drag it outside of it, then it won't appear in the game view, as you can see here. However, if it's inside, that's what it'll appear in the game view, and it's what the player will see. Just a side note. Okay, so now, the third thing you want to do generally is to start adding functionality, and kind of start like with the you can at this point you can kind of start branching out into different paths now that you kind of have a foundation of what the game looks like. So in this case, I'm going to start working on player movement. So as we know, scripts are what control movement. So we're going to make a new script by hitting right-click in the assets and clicking C# script, and we're going to name it player movement. Remember, there can't be any spaces, or else it'll break down in the C# script name. So now we can take the player, select the player, it's loading. Select the player, add the component player movement, because player movement is a script and scripts are components, and then it works that way. So now we can double-click player movement and give it a second. Visual Studio doesn't take as long as some imports on the asset store, like you saw before. There you go. So we have our script, and we want to code some basic movement. Let's see. How should I show you this? There's two ways. I'm going to show you the kind of intuitive way, more intuitive way. And then I'll show you in comments the more proper way to do things. So basically, let's see. Player movement is controlled by inputs, right? Here's where we're going to start learning to. Here is an example of an application of the input class. Basically, what we can do is you can translate, right? So you can take the game object of the component, make sure it's not the capitalized game object, because that's a class and that's not the actual object in the view. Actually, wait. No, that's stupid. That's stupid. Actually, no. Yeah. Don't take the game object. Take the transform of the object, because the transform is what holds the position of the object in the scene. Transform dot translate. Right? I think you've seen translate before, maybe. So basically, what translate does is just moves things in a certain direction, and the direction is specified in here. If you press Control-Shift-Space inside of the parentheses, you'll see kind of a bunch of parameters that you can put things in. Basically, you can cycle through the parameters by hitting the up and down arrow keys. So the parameters we're going to be using are, just for intuition's sake, is transform.translate float x, float y, float z. And basically, they're just numbers. Basically, what this does is every time this code is called, it'll move the number of units in the x parameter left to right, the number of units in the y parameter either up or down, and the number of units in the z parameter forward and backward. Since this is 2D, we're going to ignore the 0. We don't need to change the 0, so we're just going to set the float to 0. But you learned in the inputs in the inputs lesson that there's something called input.getAxis, and that responds to whether you press the left and right arrow keys. So what you can do is, because we want right now we're typing in the x parameter for translate because we're trying to make it move left and right. So we want to use the getAxis horizontal function, which will give us a number depending on whether we're pressing the right and left arrow keys, which you can kind of guess should mean movement from left to right. So get input.getAxis horizontal, and then if you could probably guess, input.getAxis vertical is for vertical movement using the up and down arrow keys. And then since we don't want to move at all in the z plane, in the z-axis, we just set the z-axis to 0. Note that you can easily see which parameter you're working on right now by seeing which parameter is bolded. So basically, right now, since my cursor is after the second comma, it's giving the input for the third float. Okay. So anyway, now basically what this does is every update, it'll check the value of getAxis and the value of getAxis vertical, and then it'll move in that by that much in the x and y directions. So now if we play the game, make sure the script has been saved and has been added to your player, and now your thing moves, I guess. Wow. Oh, it's kind of shaky. It's kind of fast, and that's because it's moving by this much. It's moving by about one unit every frame. So basically, Unity, since it can be like between 30 and 60 frames per second, this means that every second you're moving 30 units. That's pretty fast. However, here's something new. Like I said, you'll be learning some new things. There's something called time.deltatime, and basically, this is the number of seconds per frame. Basically, intuitively, you can call it a very low number. And basically, by multiplying by that low number, it takes, instead of moving at 30 frames per second, you're multiplying 30 frames per second times, you're multiplying 30 units per second, 30 units per second times like a really low number, and now you can shrink that number to like 2 units per second. So basically, that's what time.deltatime does. That's just an intuitive kind of understanding. Eventually, you'll understand why delta time is used instead of some random small number like 0.005. But for now, times time.deltatime for each of these, and basically, now it's moving really, really slow. Oh no! So now we know that since it's moving so slow, we kind of want to increase the amount it moves, right? Increase the speed at which it moves. So what we can do is we can actually make it easy on ourselves. Instead of having to go back into code and multiplying these values by some number like 5, because basically we can basically what we can do is take remember what I taught you? There was you can make things appear in the editor by typing in public variables. So if we type public float speed, what will appear in the editor is in the script section, there's a speed variable. So now what we can do is multiply this speed variable times input.getAxis and speed times input.getAxis. And basically what that'll do is it'll increase the size of each step, increase the speed of the player, I guess. So, however, note that the speed is 0, which means that if you run the code, it'll get the value of the value of getAxis, but then it'll multiply it by 0, and then the player won't move anywhere. So basically what we want to do is we want to actually set the speed to something. I'm setting it to 5. And now, the player moves more reasonably fast. Yay. Okay. So, let's see. So that's kind of the more intuitive way of doing player movement. However, technically the proper way is to actually to do this. Let's make a new line. Technically the proper way is transform.position is equal to, well, actually plus equals a new vector, input.Getaxis horizontal. I'm just going to type out a bunch of gibberish that might not be understandable. But I'll show you that it's technically proper code. Getaxis vertical. And then 0. And then you multiply that by time.Deltatime. And then you multiply that by speed. Technically, this is the proper way to do it. It's kind of hard to see, but I had to increase the screen size just to show you this. Basically, you take the transform and you add a vector. And then you add a new vector to it. Actually, this is vector 3 because there's only a vector 3 class and vector 2 class. And then you basically what this does is it creates a vector. What you learned was like a matrix, and that can represent a position or movement. In this case, it'll represent movement because we're adding it to a position. And then we're multiplying all of the units by time.Deltatime, and we're multiplying all of the values by speed so that it moves faster. So basically, if we comment this out and we show you how the code runs, whoops, the same thing happens, except actually it's a little bit smoother actually, but it's pretty interesting. So I'm actually just going to stick with this transform.position and then adding a new vector, and then multiplying all of them, all the values by time and speed, because it kind of works better. You can kind of copy this, and you can ask us to break it down for you later. But for now, I'll just leave it with this. Okay, so now we have player movement, kind of. Now we want to kind of have make the turrets shoot stuff. So basically, now we're working on the turrets. And in order to change turret behavior, we make a script specifically for the turrets. We'll call it shoot because that's what the turrets do. Shoot turret, and then we pick the turret, and then we add the shoot script. By now you should be familiar with adding scripts by using add component. And then we can open up the shoot script, and right now it's empty. Okay, so basically a quick overview of what the turret technically does is it instantiates bullets. So basically there's a function called instantiate that scripts have that basically allows them to spawn objects. I think we taught you this before, but well, we're actually going to use it right now. So basically what we want to do is first make things might be a little bit weird. There's going to be a lot of new things in this script. But first, we're going to make a function. A function, in this case, that doesn't return anything, so it's void. Void shoot one bullet. And then all functions end with parentheses and then brackets. Basically, what we want to do is instantiate. Notice that there's a thing. It appears in the autocomplete, and then we can make a game. It asks us for a game object to spawn, what we'll actually do is we'll actually make a public game object variable, and we'll call this bullet prefab. You can kind of guess where this is going. We're gonna make a prefab out of the bullet, and then we're gonna drag it into the slot that's created. So now what we can do is add the use a bullet prefab in the instantiate method, and now the next thing, however, is that shoot one bullet isn't actually called anywhere. So basically, when the game runs, it's not in start, it's not in update. So basically, Unity won't spawn any bullets. However, I'm going to show you something new that will allow you to spawn bullets in like set periods. Normally, if you call shoot one bullet in update, every frame is going to spawn a bullet, which means that you're going to end up with 30 bullets per second or 60 bullets per second, and that's not really very easy to play against. However, there's a function called invoke, and there's a function called invoke repeating. Basically, what invoke repeating does is it takes the name of the method that you're using, shoot one bullet in this case, and then it asks you for a delay. In this case, we can give the player time to prepare, 3 seconds to prepare. And then the repeat rate basically tells Unity how much time in between each call of shoot one bullet, to wait before it calls it again. Basically, what invoke repeating does is it calls a method repeatedly every few seconds. So let's make it so that Unity shoots a bullet every half a second. Notice there's a red underline because what invoke repeating is asking for is a float. So if you remember, floats end with an F, so you just type in an F, done. Okay, now, what will happen now when you run your script is that it'll probably crash because bullet prefab doesn't actually have anything stored in it. So now, in order to finish up, continue working, we have to make the bullet prefab, and then we drag it into the bullet prefab slot we made because we added this public game object. And now, when we run the game, see over here, it's creating bullets. However, they're not really showing up because the thing is, they're all spawning under the turret and they're not moving. So what we'll need to do is now, like, you can kind of see how it's kind of game development is kind of branching out into different paths. Right now, we're shifting from turrets to making turrets shoot to making the bullets actually move. So in this case, what we'll have to do is, since bullet moving is a behavior, we'll have to make another script. Create C# script. Bullet move, I guess we'll call this. And now, whoops, that's not what we're looking for. We want to open up the script. Now we're working on the bullet move script by double-clicking on it. In Visual Studio, if you, just a side note, maybe this was obvious, but you can switch between scripts by clicking on this top bar. Okay, back to the main thing. Bullet move. Basically, what we want to do is we want to make the bullets move to, according to this game, we want to make them move to the left. So if you remember what we did in our player movement, we either used translate to move it or transform that position to move it. We add a direction of movement to the transform that position. So basically, now what I'm going to show you is kind of a more kind of take this weird transform dot position syntax and make it a little more readable. Let's do this. Transform dot position plus equals vector 3 dot left. So if you reading this, it's not as intuitive as translate perhaps, because translate you can kind of tell because each of the parameters correspond to x, y, and z. How much it's going to move to the right, how much it's going to move up. However, you can kind of guess that what we're doing here is we're changing the position such that the position moves left. That's kind of how you can understand it. So now, if we, and obviously, we want to, if you remember in the player movement, we had to multiply things by time.delta_time in order to make them not move at light speed. So time.delta_time. We multiply by time.delta_time, and now when we run the game, first notice that we well, actually wait. Oh yes, we have to add the script to the bullet. Now if we try and add the script to the bullet here, it will add the script. However, notice that it's however you look at the actual prefab that you made doesn't have it. So make sure you select the prefab here, and then you click add component, and then choose bullet move, because that all of the prefabs now have the bullet move script. Okay, so now what will happen is it'll move. The bullet's going to move towards the green square. And also, if you paid attention, after like 3 seconds, this orange thing started spawning bullets. So, and they're actually moving. So, we actually it's starting to look more like the game. However, there isn't whole lot of actual interactivity between the bullets and the player and the green finish line. If we try and kind of go to the hover over the red dots, nothing actually happens. Also notice that the red dots are kind of shooting kind of fast, and also notice that when they touch the green finish line, they don't actually end the game or restart the game. So basically, what we'll have to do is those are our next 3 objectives. Again, alluding to the concept of game development branching out once you hit a certain point, after you've built your foundations. So, what we want to do now is kind of add interactivity to the bullets. Well, actually, no. There's a couple ways you can go. Actually, what I think is more important is, for now, or easier, is to actually make the bullets spawn in the right place. Notice that if you move the turret around, and then you kind of run the game, and you wait for the bullets to spawn, they'll actually spawn over here. This is because the bullet, the position of the bullet prefab is actually set to something already, so it'll start spawning here. However, it's spawning in that position. This position is actually 3.1 and 2.65. However, we can change this by going to the shoot script, which you know is the script that causes bullets to fire, as you can tell from clicking on the turret. So we can look at shoot, and instantiate, we can use the Control Shift Space tool to look for extra parameters. So we can look at looking at this. Let's make it larger. Looking at this version of the function, it takes an object. It takes a position and a rotation. So this is how we're going to spawn the the bullet in the proper place. Basically, we want to spawn it at the position of the turret. So we do transform that position, and this gives us the position of the turret because shoot is attached to the turret. And then quaternion rotation. This one's a little wackier because you haven't learned what quaternions is. Well, actually, it's actually really hard to teach quaternion because they're unintuitive. So for now, just type in quaternion.identity. They actually take 4 parameters instead of like the 3 that you see over in here. There's a rotation. There's an XYZ. Quaternions take XYZW, and the W is an imaginary number. It's really weird. Basically, just type in quaternion.identity just so that things work. And now, when you run the code, the bullets start shooting out from the hexagon. So that's another advancement. Okay, so let's try and move a little bit faster. The first thing we can, another thing we can probably do is probably make the Turtle Prefab, so that we can duplicate it, and then we can duplicate it by dragging it into the script, into the scene view, like that. And then we can remove the bullet because now we have things spawning. Let's see, we can space this out as you like, and if we run the code, if you run the game, wait 3 seconds, and they start shooting stuff. Okay, so as cool as that might look, it's really hard to eat them all up, and second, it's kind of predictable. So even if it were difficult, it's not that fun. So basically, what we can do is we can add. First, we can make the bullets harder to grab by increasing the speed of the bullets, and second, we can make the bullets start shooting at random by using there's a random class that Unity provides you. Basically, the first thing we want to do is we want to look at the bullet prefab, click the bullet prefab here, and we want to add a script, and we want to modify the bullet move script. Remember how we control the speed of the player by multiplying the change in position by speed? Well, you can do the same thing for bullets. So in this case, we can do public float speed, just like we did in player movement. You see public float speed. That'll create the field that you can add variables to. The public float speed, and then you can multiply the vector 3 that tells that changes the position such that the position moves left. You multiply that by speed, so speed times vector 3.left, and that will make the vector multiply the width, the magnitude of the vector such that it changes the position more with each call. So that it makes, basically, in layman terms, it makes the bullet move faster. Okay, so now, wait for it. Bullet move has a speed. We can set the speed to 5. And give it a sec. There we go. Now it's looking like something. Let's see. So we made the bullets move, but now we don't have a lot of interactivity. So here we're gonna. So far we've shown you a couple of new things, but at this point we're gonna show you a bunch of new stuff that might be hard to follow along with, but we're gonna have to. Since game development requires a lot of knowledge, a large expanse of knowledge, we're kind of gonna have to roll with the punches. So basically, interactivity requires something called colliders, and you might have seen these before. Basically, colliders cause basically they can trigger interactions, or they can basically simply be used to keep objects from like running through each other like ghosts. So basically, the bullet prefab takes a circle collider. If you open the prefab like this, it'll take you to a thing, kind of a local world for the prefab. And notice that there's like a green line here. If we click Edit Collider, you can see the outline of it. And we can modify the collider like this. But basically, there's a green line here. It's a little bit hard to see here. But if you make it yourself, basically that's where the collider is. That's where the bounds of the object are. And basically what we can do is that we can cause code to run when the bullet hits something. So basically, in our game, when the bullet hit the player, the bullets disappeared. And when the bullets hit the green bar, they restarted the game, like you see here. So what we want to do is have both of those, is check each time the collision happens, check for whether it's the player or if it's the win, or if it's the finish line. If it's the finish line, restart the game. If it hits the player, destroy the game object, the bullet, destroy the bullet. So the function to do that is called void on collision enter 2D. And at least the function name is a little bit intuitive, but from here on out it might not be so intuitive. Basically, collision is kind of like, it's a data structure. Think of it like a piece of paper holding a bunch of data. Think of it like, I guess, I don't know, I guess receipts. Receipts hold like numerical data. How much of this you bought, how much it costs. In this case, collision holds data on if you click collision dot, you can see all the things that the collision holds. It gives you the rigid body of the thing that collided with it. Gives you other things. We're more interested in the transform right now, because the transform can lead us to the name of the game object. So basically the name of the game object is actually whatever the name of the object over here. If you select an object and you look over here, that's the name. So basically we can use this to identify things. Basically the name of this game object is finish line, the name of this thing is player. And now we can use a comparison. Basically we can use a comparison to create a boolean, and we can use the boolean in an if statement in order to make code conditionally run. In this case, we can make the boolean collision.transfer.name is equal to player, because we want this code to run when the player touches and when the bullet runs into the player. We can use an if statement. If collision.name is player, now you're seeing it's returning back to intuition. If the name of the collided object is player, then destroy this. Now, there's a problem with this actually, and this, because this does not actually refer to the object in game, it actually refers to the script. So it'll actually remove the script but not the object. So basically what we want to do is actually do this .game object, or you can just type in game object. Game object. Make sure the first G is not capitalized, because the capitalized G is a class. So basically now, if we run the game, okay, the bullet should come out any second. There we go. Okay. However, here's the thing. Notice how the bullets didn't disappear. This is because the player needs a collider of his own. So basically what we can do is add a component. There's multiple types of colliders, and in this case we'll use a box collider. Because our player is a box, if you look closely, there's a green line around the player. It's hard to see up there, but you should be able to see on your own computer. And basically, that's what causes the player to interact with the world. So now, if the code runs, well, it still doesn't run. So here's the weird thing about collisions. Basically, collisions are actually part of the physics system, and by using by changing doing transform.position of the by using transform.position, we're actually not moving the player in accordance with the physics engine. It causes some weird things to happen. What we want to actually do is actually add a rigid body to the player. Again, this is becoming very unintuitive. I'll probably have to rush through this a little faster. There's a rigid body 2D specifically for 2D games that causes it to react to physics in 2D. Let's see. We can set the gravity scale to 0 because there should be no gravity in the game. Let's see if this works. Yep, now it works. However, there's some weird stuff going on where the square is kind of shaking. Basically, what you can do is there's constraints in the rigid body. This constraints field, constraints category. You can freeze the rotation, and the player will stop rotating, like that. There we go. Now it's eating stuff. Hooray! Okay, so now, you probably figured that we need the finish line to have collider as well, because we want the bullets to interact with the finish line. We can give this a box collider, and the box collider should, it's hard to see, but the box collider is there, even though it's green. But we add a box collider to the finish line, and then what we can do is go to bullet.move. We want it to interact with the finish line, so we can do the same thing as where we made it interact with the player in order to make it interact with the finish line. So we can do, if the collision.transform.name, the collision object's transform's name is equal to finish line, because that's the name of this. Then, okay, some new stuff. Again, this might be important to remember though. This is called, there's a function called application. quit. Or actually, no, not that. No, my bad. That's not it. It's application dot load level 0. This is a little bit weird to understand, but basically this just loads the first level of your game. For now, since we don't have to worry about what the 0 means, because this is the only level of our game. Eventually, you'll want to figure out what it means. Also, note that there's a green line. It's because it's kind of application.load level is a little bit old, so they want you to use Scene Manager. However, because that requires another import like this, using, which we haven't taught you yet, and you probably haven't looked up yet, we'll just use application.load level for now. So now, if we do this, we know the finish line has a collider, so we know the bullets might run into it. However, remember that the finish line does not have a rigid body, so we have to tack on either a rigid body to the bullets or a rigid body to the finish line. Just to make things simple, we're going to add it to the finish line. Rigid body 2D. For now, like just the basic understanding of rigid bodies is that you make collisions work. So in this case, gravity scale is 0 because we don't want it to fall off. And then nice. It reloads the game. Okay, so now we got the bullets to reload. The final step is we're actually almost done here. The final step is just to make it so that the bullets appear at random, like here, like you see here. So basically what we can, in Unity, there's, we'll do this pretty quickly. There's, in shoot, because this is the thing that controls the turret's shooting, we can make the turret shoot randomly by editing the shoot script. So basically, in shoot one bullet, we can actually make it roll a dice, and if the dice falls within a certain range, then it'll spawn a bullet. If not, then it won't. And this will add an element of randomness to the game that can make the game a little more fun. So let's do this. Random. We'll use an if statement here. If random.range is and the range is basically like a lower bound and an upper bound. Basically, you can set it to 0 to 1. However, notice that this kind of transforms to int. We'll see what happens. We'll see what happens if we leave it this way, because something really weird is going to happen. If random.range is between 0 and 1, and it's less than 0.5 f, and it's less than 0.5, you can make it f if you want to, but it doesn't matter right now. Then instantiate. So supposedly, and then just to make things a little bit faster, we can increase the spawn rate. So supposedly, intuitively, you would think random. This should, if basically random.range gives you a random number in between 0 and 1. And basically what we're doing is if that random number is less than half, then it'll spawn a bullet. However, if you run the game, what'll actually happen is it'll spawn bullets every time, and even faster than before because we changed the delay between function calls. So what's happening here is basically if you look at the parameters, they actually take ints, and it says in the description returns a random integer number between the minimum 0 and the maximum 1. So because the maximum is exclusive, the only integer within the range 0, 1 that does not include the 1 at the end is 0. So the return value will always be 0. What we'll have to do is force these numbers to be ints by tacking on an f at the end of them. And now if you control shift space, you can see that it'll give you a random float number between 0 and 1. That can be 0.2, 0.5, 0.7. And now if we run the code, now it spawns randomly. And now you have a very, very rudimentary game. Basically, you can kind of tweak the difficulty how you want. You can reduce the speed at which bullets are shot, like this. so that you can make the game a little bit easier. You can increase the speed of the bullets as you will. That looks a little more playable. You can make it less orderly by reducing the range of the random, by reducing the threshold for bullets to spawn. But basically, now you kind of have a basic game that you can kind of play around with. If you basically because we're done with the game, we're kind of done with this now. But I can show a few things that will make it kind of more application-y. If you're interested. However, I guess considering it's 4:26, I'll probably stop here. So yeah, you can kind of see the process of game making. It starts with like your game idea. In this case, you wouldn't have this image here, but you would kind of have in your head an image like this. And then once you have an image in your head of the game, you start by making kind of objects that you would see in here. You would make you start by making representations of objects in the hierarchy. Then you start making them visible so that they're more tangible, like how I added scripts. And then finally, you move on to adding functionality, and that can take you on a kind of a roller coaster ride in terms of direction. But that is kind of the process of game making, and I hope that you through this you can replicate it in your own game design and your own game design adventures. And I hope you come up with great games. I hope you come up with great games. So thank you. Oh.